Hello math students, what an exciting journey it has been, right? From finding the gradient from first principles to applying the differentiation rules up to so far, you must have gotten a lot more information on how to solve these problems, right? So just before we get into this interesting subtopic, right, which is application on tangents, right? I just found some questions here that I would like us to look at, just to see if we, how far we are with them. So the first question is this one. This is just a recap from what we've been doing as we were applying the rules. So I just found this question and then I thought, this question is very interesting. Let's try to look at it, solve it, and then we can see how far we are. All right, so you are given y is equal to this, right? This is your y, and then you are given that 8x, right, is equal to p to the power negative 3. Then they give you this and say find dy over dp. Okay, so now what you should first realize is that we have dp here. What does it mean? It means the variable we're working with is p, and then, or rather that we are respecting is p, and then our equation is y is equal to something. So it means, first of all, we need to simplify this in order for us to have p as the instead of working with x, we need to be working with p. So how do we do that, right? So first of all, this is what we're gonna do. We know that 8x is equal to p to the power of negative 3, right? If I were to make x the subject of the formula, it means I'll divide by 8 both sides. Therefore, this would mean that this 8 will cancel that 8. It means our x will be equal to p to the power negative 3 all over 8. Okay, so this is our x there. Now this x, where we see x, we're gonna put it in that equation there, right? So now for our y, right, y is equal to 6, and then we have the cube root of x squared there, right? If we were to simplify this, we can write it as 6, and then we can say x. Now remember, if you watch my previous videos, I take the exponent, then I take it up, then the denominator becomes whatever is the root, right? So in that case is 3. So this is what we have. Now that we know that this is x, remember, right, this is our x here, right? So we're gonna substitute that x into the equation there. All right, so we're gonna have 6 into, where we see x, we put p to the power negative 3 all over 8, and then all over 2 over 3. Okay, now it seems it seems a bit challenging, isn't it? So but do not panic yet. We're gonna work through it step by step, right? So now that we have this, we can write this as, remember, p to the power negative 3, and then this 8, remember, you can write it as 2 to the power of 3, right? If you do not know how to get this, you can just go to your calculator, you press 8, and then after that you press the equal sign, and then after that you press the shift button, and then after that you press the fact button. There is this button there that is called the fact button. You should probably see it with some symbols like this. I think they are like that. There's something like this, but it should have it should write fact in yellow. If you're using a Casio calculator, then you will find that 8 can be expressed as 2 to the power 3. We call it a product of its prime factors, right? So now now that we know that, now we can apply the laws of exponents, right? Remember, calculus is all about application of algebra, so we do not forget our laws. We know that if I have a to the power n all over b to the power m all raised to maybe p, I know that I'm gonna say a to the power of n times p all over b to the power of m times what? Times p, meaning these exponents are gonna be multiplying each other there. Okay, so we're gonna do a similar thing here, so that we now have 6 into p to the power of negative 3 multiplied by 2 over 3, right, by 2 over 3, all divided by 2 to the power of 3 multiplied by 2 over 3, right? So I'm multiplying this exponent by that, and then I multiply this exponent by that. Okay, so now what will we have there, right? So I just wrote it down here. So now we have our y is equal to this. Now if we were to simplify this, right, we're gonna say we have 6 into, now what is negative 3 times 2 over 3? That will be p to the power of negative 2, right? Then all divided by 3 times 2 to the power 3, that will be 2 to the power 2. Okay, so now that we'll have this as our y, it means our y will be okay, we can write it as 6 and then times, this is a denominator. I'm gonna take it up to be a numerator. Remember what we said in our previous videos, that when we take it up to be a numerator, the exponent is gonna change the sign. Then this one remains as p to the power negative 2. It remains as a numerator with a negative sign, then we leave it like that. So now that we have something like this, most definitely we can now say, well, remember the goal is to get it into this form, right? So this can be our a, right? Then this one here would be our n. Okay, so now that we have something like this, we'll then now say, remember when I now applied the rules, I was just simplifying, right? Now I'm gonna say dy over dp, right? Remember the variable is p, right? So I'm gonna say this a times n. Okay, so I'm gonna say 6, right, times 2 to the power of negative 2, then times negative 2. Okay, and then I say p, then I say the exponent minus 1. Then all you do now is to simplify. If you can just put this into your calculator, right, put that in a calculator, you should get the answer should be negative 3, right? It should be negative 3, then p to the power of negative 3. Okay, so this is your dy, right, over dp, right? This is your answer there. Quite an interesting question, isn't it? Quite an interesting one. Just required a bit of working, right? But I know that as you are doing more and more problems on this, you are becoming more and more equipped with techniques to use, isn't it? So that is how we solve that. Just before also we go to a graphical application, let's look at the next one. Let's look at this one here, right? Just to reinforce the issue of using the rules. Okay, so this one says determine this, right? So how do we solve it for 6 marks, right? This means we're gonna work a lot. But remember, whenever we're working with dx, when we are simplifying, remember when we are simplifying, we always write dx, okay? Outside, we always write dx. So I'm gonna simplify this because we wanna remove all these radical signs, all these denominators, so that we get our expression in this form, okay? All the terms in this form. So here I have 15, then I have times x. As always, good people, you can try it and then see the solution afterwards. Now exponent is 4, right? Remember, if you watch my previous videos, you will then know that I always take this exponent up to be the numerator, then the root, which is 5 there, I take it as the denominator. Okay, so this is what we will have there, 4 over x to the power of 4 over 5. Then we have minus. Now remember that this denominator is going to be dividing all the numerators on top, right? We have a similar problem we did like this in our previous videos on differentiation rules, so please kindly check it out. So here we're going to say okay, it will be wise to use a bracket. Because why am I using a bracket? Because there's a negative outside, and then we get this. So I'm gonna use a bracket and say I have 3x to the power 7, right, all divided by the denominator, which is 4x to the power 3, right? And then we're gonna say plus x divided by 4x to the power of 3. Okay, then we close that, then we close the big bracket. Okay, now remember, I'm still simplifying. I have not applied the rules, so that's why you see it written in yellow there, right? So this one here would then say we have negative into Then we have 3 divided by 4, isn't it? It's just 3 divided by 4. Then we have x to the power 7 divided by x to the power 3. Remember, bases are the same, so you're going to subtract the exponents. So you say the exponent on top minus the exponent on the bottom. Then we say plus, here it's 1. Even though they don't write it, it's 1, right? So we just have 1 over 4. Then we have x and x to the power 3. Remember, bases are the same. The exponent there is 1, even though they don't write it. So we're going to say 1 minus 3. The exponent on top minus the exponent on the bottom. Okay? Then we have this. So we still continue to simplify. Then we'll have 15 x to the power 4 all over 5, right? Then we'll have minus into 3 over 4 x to the power 4, right? Because 7 minus 3 is 4. And then we have 1 over 4 x to the power of negative 2. Okay? X to the power of negative 2 there. Then now, as we continue to simplify, we're going to say we have 15 x to the power of 4 over 5, right? Then minus 3 over 4 x to the power 4. Then minus, remember the minus is just multiplying inside there. So negative times positive is negative. Then you have 1 over 4 x to the power negative 2. Okay? Then you have removed these brackets inside. Now that everything is now in this form, now we're going to apply the rules. That's why you see me writing it in white now. So when we apply the rules, what are we going to say? We're going to say the number here times the number there. And remember, we no longer write dx. So we just say the number here times the number there. So we're going to have 15 multiplied by the exponent, right, which is 4 over 5. Then you have x. Then you say 4 over 5 minus 1. Remember, you always subtract 1 from the exponent. Then you're going to say this number times that number, right? So you're going to have negative 3 over 4 multiplied by the exponent, which is 4. Then you have x, 4 minus 1. Okay? Then after that, you say this number times that number. So you're going to have negative 1 over 4 times negative 2, right? Your brackets. And then x to the power of negative 2 minus 1. Okay? So now, what is 15 times 4 over 5? 15 goes once into, okay, 5 goes once here. And then into 15 goes 3 times. So you have 12. And then x, what is 4 over 5 minus 1? That will be negative 1 over 5, isn't it? That will be negative 1 over 5. And then negative 4 times 4, that will be negative 3. You can just use a calculator. Good people, put it in your calculator. You should get negative 3. And then you have x, and 4 minus 1 is 3. Then what is negative 1 over 4 times negative 2? Well, the answer should be positive, because negative times negative is positive. Then 1 over 4 times 2 is half. Okay? It's half, and then you have x to the power of negative 3. Then you got your solution. Now remember, if they want you to leave it in positive exponent, you can just say 12. Then remember, as a numerator, it has a negative exponent. As a denominator, it's going to have a positive exponent, right? And then here you're going to say negative 3x to the power 3. And then here you're going to have 1, and then the denominator is 2. Then this is going to join the denominator, but the exponent would be positive instead of being negative. Okay, so that is how we solve it. So quite a beautiful question there for 6 marks, right? But it's just a matter of applying your rules, right? And then I'm hoping that you are now comfortable with that. Now to the business of the day, right? We have a question here, right? It says that is a linear function, and then determine that and that. Okay, well, first of all, good people, let's revisit this notation here. Let's understand that, let's say I were to have a function here, right? Let's say I were to have any function. I'm just gonna quickly sketch this function here. Sorry, now let's say here you got a point which is maybe 3 is to 2. Okay, so, and then this is maybe f of x, right? Let's understand that what is the x value there? X is equal to 3. What is the y value? The y value is equal to 2. But remember, this y value, we can also write it as f of 3. Okay, so f of 3 means this is the y value when x is 3. Okay, what about here? If I have -1 and then let's say I have 2 there, right? I can say my x is -1, my y is what is 2, but this y I can also write it, right? So I'm gonna write it like this: my y is also equal to f of -1, and then it's equal to 2. So this y value can also be written as f of -1, and then it's equal to 2. So what this means here is that this is the y value when x is -1. Okay, so this is the y value when x is -1. Okay, so I just need you to be careful of that. If I give you maybe f of 10 there, this means whatever I get here is the y value, right? Is the y value when x is 10. Okay, so it means as a coordinate I can write it like this: x is 10, and then I'm gonna say the y value is f of 10. This is the y value. Okay, so it's very, very important to understand that notation. If you can understand it, believe me, you're gonna master calculus effortlessly. So let's say g of 7, right? G of 7 means the answer that I get here is the y value, right, when x is 7. So as a coordinate I can say my x is 7, my y is g of 7. Are we clear? So remember, this one here is the y value when x is what? When x is 7. I hope that was clear. So let's tackle these questions here, right? It says g is a linear function. So we need to read these questions carefully. G is a linear function. So if it's a linear function, we know that we are dealing with y is equals to mx plus c, right? Which means if I'm talking about g and then I'm talking about the variable x, so I can say g at x is equals to mx plus c. This is a linear function. Okay, that is a linear function. Now it's just a straight line, right? So remember what is m? Remember m is your gradient, right? M is your gradient. Then what is c? Remember c is your y-intercept. Is your what? Your y-intercept there. Okay, so that is what we have there. So the question says, since we have that linear function, we are told that g of 1 is equal to 5. What does this mean? Take a minute to think about it. What does this mean? Yes. What is this here? It's x. X is 1. What is this here? Y is 5. This means g of 1 is the value of y when x is 1. Is the value of y when x is 1. So what does it mean? It means as a coordinate, this thing here, I can write it as 1. Then I can say g of 1. This is x. This is the y value when g is 1. So we know g is 1 is equals to 5. So it means we have 1 is to 5. Because g of 1 is 5. Meaning the y value when x is 1 is 5. Okay, in simple terms, this is just the x value there. This one is just the what? The y value. Alright, so let's be very, very cautious of that, right? I think I should even make more examples so that this thing sinks in. Okay, if I give you g of 3 is equals to 10, you must know that this means x is 3 and then y is 10. And this can also be written as 3 is to g of 3. When do I write g of 3? When I do not know what is the value of g of 3. But if I know that g of 3 is 10, then I'm gonna write 3 is to 10. Okay, one more time. Let's say I give you g is to -7 is equals to 2. What does this mean? It means my x is -7, my y is what? Is 2. Okay, my y is 2. Or we can write this as my x is -7, and then here I'm gonna have g of -7. This means the y value when x is negative 7. And what is that y value? It's 2 when x is negative 7. I hope that is clear. Okay, so let's also now understand that there is a difference between g of 1 and g prime of 1. G of 1 is the y value when x is what? 1. While this one here means is the gradient at a point where x is 1. So this means the gradient at a point where x is 1. Alright, for it to make more sense, let's just say we have our function again, right? Let's say we got our function again like this, right? And then this is, let's say it's f at x. Let's just give it x squared, right? Suppose you know the x value here. Okay, suppose you know the x value here. The x value is 2, ne? So you know that x is what? Is 2. What is the y value? To get the y value, you substitute x as 2 in this equation. So you're gonna say f of 2 will be 2 all squared, which is equal to what? 4. F of 2 is equal to 4. Now what does this mean? Remember, x is 2, your y is what? Your y is 4. Okay, so it means as a point, this is 2, and then this is what? This is 4. It means here the y value is what? Is 4. However, this is different from the derivative at 2. This means now the gradient at x is equals to 2. So what does it mean? It means you first need to find the derivative of the graph. That's why you see f prime. So to get the derivative of f, now you know how to apply the rules, right? So you can just say the derivative of f is equal to the number that is here times the exponent, right? So it will be 1 times 2, right? And then you say x, and then you say the exponent minus 1. So the derivative of f would be equal to 2x. Now if I substitute 2 here, if I substitute x as 2, I'm gonna put it where I see x, right? And then I get the answer as 4. What does this mean here? This means at 2 here, the gradient, right? This means the gradient is equal, right? The gradient is equal to 4 at the point where x is 2. This is a point where x is 2, right? At that point there, the gradient is equal to 4. Okay, the gradient is equal to 4. So it tells you that f prime of 2 is equal to 4 means the gradient is 4 at x is equals to 2. So if we were to look at this point here, it means here the gradient is 4. So what does it mean? If you were to draw a straight line that passes through that point, right, that straight line is gonna have a gradient. This straight line here, right, is gonna have a gradient that is equal to 4, and that gradient is positive, isn't it? Which makes sense because this line here is increasing. Okay, so please, good people, I was trying to emphasize the difference between this thing here and this thing. Okay, this means the y value is 4. This is the y value. It's 4 when x is 2. While this means here the gradient is 4. Okay, the gradient is 4 at x is equal to 2, at this point where x is equal to 2. And what do we call this line? It's a tangent. That line is a what? Is a tangent. Why is it a tangent? Because it touches the graph at only one point. So this means that the gradient of this tangent is 4. That's why we usually write it in this way. We usually just write m of a tangent will be equal to 4, because this is the gradient of the tangent line. Okay, I hope that is clear. So yeah, that was a mouthful. Please write these notes down so that because if you want to understand this whole thing here, then it is important to understand that. Okay, so now it says g is a linear function, right? So we know that g of x is equal to mx plus c, right? G of 1 is 5. It means g of 1 is what? Is 5. It means we have a coordinate or a point where x is 1, and then what is y? Y is 5. Okay, so remember this is your x, and then this one here is your what? Is your y. Right, so determine the equation of g. We are also given that the gradient at x is equal to 3 is 2. Okay, so we are given that g prime 3 is equal to 2. It means if I were to have the graph of g, right? Let's say this is the graph of g. Okay, let's say this is the graph of g at x. It means at a certain point here, where x, what is our x? Where x is 3, and then we do not know the y value, so I'm just gonna write g of 3, right? We don't know the y value. It means at that point there, the gradient is what? The gradient is 2. Okay, the gradient is 2 at that point there. All right, so they want the equation of g at x. So it's not gonna be difficult, so we just say, okay, since our g at x is equal to mx plus c, right? What is the gradient of that function? We were given the gradient at 3. What would be the gradient at 1? Because there is another point here, right, which is 1, and then y is 5. What is the gradient at that point? You must know that a straight line, a linear function, the gradient is the same at all points. Meaning if I were to calculate the gradient here at this point, the gradient will still be 2. Okay, if I were to get the gradient here, the gradient will still be 2. And even here, the gradient is what? Is 2. So the gradient is the same throughout for all straight lines. So therefore, we already know that g at x will be equal to 2x plus c, because the gradient is 2. So now, how do we get the full equation? How do we get c? All the time, even if you have to sing this, all the time to get c, you're going to substitute a point. Okay, all the time to get c, we are going to substitute a point. This is our point here that we have x, we have y. So where I see x, I'm gonna put 1. Where I see y, I'm gonna put 5. Okay, so remember, this stands for y, isn't it? That stands for y. So where I see y, I'm gonna put 5. Where I see x, I'm gonna put 1. Right, then I'm gonna have 5 is equal to 2 plus c, which is 5 minus 2 will be equal to c. Therefore our c will be 3. So therefore the equation of g is equal to 2x plus 3, of which you can also write it, they said, in terms of y, right? So instead of writing g at x, I can say y is equal to 2x plus 3. Then I got my 3 marks there. So it is very, very important, good people, to understand that they gave you this so that you are aware that they gave you this so that you are aware that the gradient is 2. But they said the gradient is 2 at x is equal to 3. As we know that on a straight line, the gradient is the same everywhere. So that is why we just say this 2 will be the gradient of the straight line. Okay? That 2 there will then be the gradient of the straight line, because the gradient of a straight line is the same throughout. I hope that is clear. Okay, so the gradient of a straight line is the same throughout. We got that it is 2, we substitute it there. Then to get c, we always substitute a point. So we substitute this point here, 1 and 5. Why didn't we substitute this point, 3 and g of 3? Because we don't know why. We don't know what is g of 3. We don't know the y value when x is 3. So we can't use this point. That is why we use the point that we were given here to get c. Alright? Great. That was a mouthful. It's gonna be a long journey. Okay, it's gonna be a long journey. We're gonna tackle complex problems on this, but remember, I am with you all the way. We are going to solve this together, and then understand it together, and then we're going to move and master calculus because of that. So as always, stay tuned for more. Okay, if you didn't understand maybe properly here, remember the remedy is doing more and more problems so that you are a professional at the end. Okay, stay tuned.